One of the non-linear data structure weighted graph. One of the non-linear data structure is called as graph. This is actually a pictorial representation of a graph. The definition is a graph is a collection of points called as vertices. Sometimes it is also called as nodes. This A and C are called as actually vertices here, and these vertices are actually connected by some line segments called as edges or arcs. Graph can be represented as G is equal to V comma E. Here two defined pair of sets are there, V and E. V means actually a finite non-empty set of V. A finite non-empty set of items called as vertices. For example, see here A, C, B, D, E, F. These are called as actually V. A set of V, a pair of these items is called as edges. Here E indicates a pair of these vertices. Okay, next I will explain how actually it will do. Now see here, there are two types of graphs are there. This graph is called as actually undirected graph, and this graph is actually called as directed graph. In undirected graph, the vertices are A, B, C, D, E, F, whereas edge can be represented as AC as well as CA. Okay, AC, CB, BF, FE, ED, AD, CE, like that one. These are actually called as edges of the undirected graph. This is called as directed graph. In directed graph, the vertices are same, A, B, C, D, E, F, but the edges are different pairs. For example, see here AC is there, okay, like that. DA is there, CE is there, DE is there, BC is there. There is no CB, only BC, like that. Okay, like that we can tell vertices as well as edges. Now consider the first one is called as undirected graph. What is the meaning of undirected graph? If all the edges in the graph are undirected, then such graph is called as undirected graph. So what is the meaning of undirected edges? Here if you consider this one as U and this one is V, the pair of vertices UV is same as VU. These two vertices A and C are called as adjacent to each other, and this edge is called as undirected edge. In simple way, if you consider this one as one city and this one as another city, there is a road between them. There is a one path or road. Now I can travel from A to C as well as I can travel from C to A in the same path. So it is called as undirected edge. Now see, A and C are connected here using undirected. So we can say that A and C are incident to this edge. Okay. Now see this graph. This is called as directed graph. In short, it is also called as digraph. In directed graph, each edges are having some direction. If you see here, instead of line, we are indicated by some arrow mark. This part is actually called as tail part, and this part is actually called as head part. In simple way, I can say, if there is a path between, if A is a one city, C is another city, if there is a path between A and C, I can travel from only A to C using this path. I cannot go back this like this. I cannot go backside. So such concept will be here. If I considered A as a vertex, for example, if I consider this one as a U and this one is considered as a V, UV vertex, UV edge is not same as VU. In directed graph, these vertices not same. C is not same as CA. Graph representations. Now, this is a pictorial representation of graph. But when we are implementing graph in computer, we have to convert that into a particular format that is called as graph representations, because graph cannot understand this picture. We have to convert that picture into computer understandable format. We can do this by using two techniques, that is called as adjacency matrix, and the second one is called as adjacency list. Graph can be represented in computer by using these two techniques. The first one is called as adjacency matrix. Now this is the graph, and the adjacency matrix of this graph is written here. So what is the meaning of that one? I will explain first. If we have n number of vertices, we can create a matrix of m into m. For example, if you have n number of vertices, we are creating n into n matrix. Here one row and one column is given to one vertex. For example, see here, this column and this row is given to A. In similar way, this row and this column is given to B. If there is a edge between ith element and the jth element, we consider this one as the I, this one is considered as the j. If there is an edge between ith element and jth element, we can represent it by 1. For example, see here.